Hello friends, welcome to Siddha.com. Now in this video we'll learn about the physical properties of alkanes. Alkanes we know are saturated hydrocarbons, and therefore the force of attraction between the different alkane molecules are weak van der Waals forces. So it is due to this reason that alkanes up to 4 carbon atoms are colorless, odorless gases, and the molecules having 18 carbon atoms, right, C18 or more than that, are solids, and the alkanes from C5 to C17, right, are liquids, right. These are the colorless, odorless liquids. So lower alkanes are gases, and very high alkanes are solids, and alkanes from C5 to C17 are generally liquids, right? So that means with the increase in the number of carbon atoms, the molecular weight increases, and therefore, the liquids change their state from gas to liquid and liquid to solids. Now what about the boiling point of the alkanes? The boiling point of straight chain alkanes increases, right? So straight chain alkanes, the boiling point increases with the increase in the number of carbon atoms, right? So that means if the number of carbon atoms increases, the boiling point also, increases. And here's an example. For example, methane, its boiling point is 111 K, 111 kelvins. So ethane, just one carbon atom more, so the difference here is what? The difference is a CH2 unit, right? And you can see that the boiling point also increases from 111 to 184. And again, when you got the C3 molecule, propane, the boiling point increases 230, C4 it is 272. That means with the increase in the number of carbon atoms per molecule, the boiling point also increases, right? The boiling point of the liquids also increases. So the graph can be like this. With the increase in the number of carbon atoms, the boiling point also increases. And with branching, suppose if you got a pentane, right? Suppose we have a pentane here. The formula is C5H12. The linear chain pentane molecule, there are 5 carbon atoms in this one. Here its boiling point is 309 kelvins, right? The boiling point here is 309 kelvins, and its isomer here, right, structural isomer, this is called isopentane, right? This is also a 5 carbon, 1 2 3 4 5. So this is an isopentane, right? For an isopentane, the boiling point is less than 309. It is around 301 kelvins, right? And if you take a neopentane, right? Neopentane is like this, right? So in the center there is a 1 carbon and there are 4 methyl groups around it. So here this is called as a neopentane, right? And the boiling point here is 282.5 kelvins. That means with the increase in branching, right, number of carbon atoms is same, the formula is same, right? C5H12 for all these molecules, right? The formula is C5H12, correct? The formula is same. So the only thing is, one we have a normal pentane, right, called an N-pentane, and when branching increases here, the boiling point decreases, right? So with the increase in the branching, when branching increases, the boiling point here decreases, okay? With the decrease, when branching increases, the boiling point decreases, okay? Why it decreases? Pretty simple. You know, in a normal pentane and pentane, the surface area here is more, and with the increase in the branching, the surface area of the molecule decreases. And we know the intermolecular force of attraction depends on the surface area of a molecule, right? So when surface area of the molecules here decreases, the boiling point also decreases. Okay, I'm going to repeat it, right? See here, the van der Waals force of attraction that you see, you know, between the different molecules, right? It depends on, okay, you can see the force of attraction. It is directly proportional to the surface area of a molecule, right? Surface area of a molecule. So what happens due to branching? So due to branching, surface area, you know, decreases here, right? Isn't it? Surface area decreases, and when surface area will decrease here due to branching, force of attraction will be less and their boiling point will decrease. Correct? Okay, fine. So hope you got this point. Let's move to the next property of the alkanes. What about solubility? We know that the solubility of a compound, you know, it's generally governed by a principle like dissolves like, right? So everybody knows it. For the solubility, right, we have a one principle like dissolves like, okay? Alkanes are non-polar, isn't it? These are non-polar compounds. So therefore, they will be soluble only in non-polar solvents, right? They will be soluble in non-polar solvents only. So what are the non-polar solvents? Benzene, very common example, CCl4, ether, right? These are the, so that means alkanes are not soluble in polar solvents, right? Polar solvents, like for example water. So these are soluble in non-polar solvents and insoluble in the polar solvents. Next is about the density. We know the density is what? Density is the mass by volume, okay? Mass upon volume. So with the increase in the number of carbon atoms in a molecule, the molecular mass will increase, okay? Therefore, the density also increases. Correct? So when the number of carbon atoms in a high, you know, in an alkane increases, molecular mass will increase. So therefore, the density will also increase. So that's why, you know, the density of the alkanes increases very slowly with the rise of the molecular mass. So that means when the number of molecules increase, molecular mass will increase, and therefore the density will increase. But the change is very gradual, right? And it reaches up to, you know, highest constant value, right? It becomes a constant then about 0.2. This is the highest density that we see, that we find in any of the alkanes, 0.8. And this data here is pretty less than the density of the water, right? We know the density of the water is what? How much is the density of water? Density of water, right, exactly, it is 1.0 grams per ml, right? Okay, so it is 1.0, and the highest density for the alkanes is about 0.8. That's why, you know, the alkanes are lighter than water. Okay, so that's why when you mix, when you try to mix, you know, water and alkane, they are not soluble, right? So it will not mix, rather you get two separate layers, right? Okay, so the first layer which is at the bottom will be the water, okay, and the second layer of the liquid will be a hydrocarbon, right? So it will be a hydrocarbon because the density of the hydrocarbons of the alkanes is generally less, right? Got it? Hope you got the concept. Thanks for watching the video. Bye for now.